Okay, question 9. Question 9 is actually a binomial theorem question. So therefore, can you see that 7 to the power of 2003 plus 8 to the power of 2003, right? 7 is actually 8 minus 1, 2023, sorry. And then 9, sorry, this is 9, right? 9 is actually 8 plus 1, 2023, right? Therefore, in this case, can I expand out this? This would be 8 to the power of, you use a binomial theorem, 8 to the power of 2023 plus 2023 C1, and then this is actually 8 to the power of 2022, and then this is minus 1 to the power of 1. Then you go all the way. Can you see that? I just want you to look at the last two terms. That means this is actually 2023, 2022, and then this is 8 to the power of 1, and then minus 1 to the power of 2022, right? And then the last term is minus 1 to the power of 2023. Then for the second expansion, here, this would be 8 to the power of 2023 plus 2023, and then this is 1, and then this is 8 to the power of 2022, and then 1 to the power of 1, right? And then you go all the way to the second last term. Therefore, second last term, you will get this, right? You can get 2023, 2022, and then this is 8 to the power of 1, right? And then this is 1 to the power of 2022, right? And this part here will be plus 1 to the power of 2023. Therefore, in this case, can you see that the term before that you have a 8 squared, and the term before that definitely have 8 squared. Therefore, I don't need to worry about the terms that is before the second last term. Therefore, I only need to worry about these two last term here, these two terms and these two terms here, right? Can you see that? Then in this case, and can you see that when you add up these two, when you add up this expression, when you add up this expression and this expression, okay, then can you see that this part here, this part here, your 1 and 1, your minus 1 and positive 1 will cancel. Therefore, and 2003 C 2022, that is basically 2023, right? Therefore, what you get here, what you need to worry is that is actually 2 times 2023 and then times 8, right? And we want to check when this number divided by 64, what is the remainder? That means modulo 64, or modulo 64. And can you see that we can actually compute quite fast in this way? That means this is congruent to 2 times 8 is 16, right? 16, and then times 2023 modulo 64, modulo 64. Then can you see that this part here, your 2023, right? 2023 is actually congruent to what? Is actually congruent to 3 modulo 4, or 3 modulo 4. Therefore, in this case, to make our computation faster, I can say that this is 16 times 3 modulo 64, right? And then in this case, I will get 48 modulo 64, right? And the remainder, that means the remainder now is just equal to 48. The remainder is just equal to 48. That's it. Okay, let me further explain. Can you see that the terms before the second last term, when you take modulo 64, right, they will always give you 0, definitely. Because it contains 8 squared for both top expression and the bottom expression. Right? Therefore, it is always 0. Therefore, we only need to worry about this term and this term. And then your minus 1 and the 1 cancel. All right. Okay, with that, I answer the question.